Uh, Hello all. This is our third part in this. So we will continue this use case sales forecasting only. Okay. Uh, because we are discussing this in detail. Okay. So by using this use case, I was trying to cover other topics also. That's why this use case will take more time. So now, in our last session, we have uh, defined this function to display scores. Okay, so from our k-fold cross validation, whatever scores will come, this function will show the uh, RMSE values of those scores, and then it will show the mean value and then standard deviation. So now, let's jump to baseline models. In the baseline models, we will be using all the features of the data set in our models. So in our baseline model, we will be using all the features of the data set. We will perform five-fold cross-validation. So first, we will start with linear regression. So base LR, and it will be a very simple linear regression. We are not providing any parameter here. So only this only. Okay. So run this. Now perform five-fold cross-validation using base LR. Uh, then use X-train as features, Y-train as target. Evaluate the model using a negative mean squared error. Store cross-validation scores in scores. Okay. So we will do cross-validation score. Then in estimator we will mention base LR. In X we will mention X train. In Y uh, we will mention Y train, and then in CV cross validation we will mention 5, uh, and for scoring we will be using uh, negative. 1 second. Okay. Negative mean square error. Okay. Negative mean square error. So run this. Hope it will not throw error due to this. Okay. So it runs successfully. Now we will be displaying the RMSC score with display score helper function. Okay, so and we will pass this and see. So it runs successfully. Here you can see that for 5 fold, for first fold, uh, the RMSE values are 21979 point this, and for second RMSE value is this. For third RMSE values this. For fourth we have RMSE value like this, and for fifth this is the RMSE value. And if we take the mean of all these five RMSE value, it is this much, and standard deviation is 195 point something in these RMSE values. After performing five-fold cross-validation on our baseline linear regression model, we get a mean RMSE score of this much. This is not a good score at all. Uh, the standard deviation of 195 means that our model is performing almost similar to each fold it was tested on. Okay, and is generalized well on unseen data. So, standard deviation of 195 means that it is because this standard deviation is not very high, so it is performing almost similar on each fold it was tested. Okay, now we will use a decision tree model. So this decision tree model is like base decision tree. Okay, we name it base decision tree and then decision tree, and we will keep random state as okay, keep it one here. Okay, now perform five-fold cross-validation using base decision tree. And same we will cross-validation score uh, estimate estimator is base decision tree X is X train, Y is Y train, cross-validation is 5, scoring is uh, negative, mean squared error. Okay, so now we are doing cross-validation, five-fold cross-validation using a base decision tree. So run this. Okay, so this is not defined. So run this first, then run this. Okay, uh, and once it will be run, then we will display the RMSE score. So it since it is a decision tree, it is taking slightly more time. Okay. Uh, so now it's run successfully. So we will display score here. So you can see here mean value is 5248, which is less than this value. It is 21,000 something, and it is 5,000 something. So RMSE value is very less in decision tree. Standard deviation is 260. So this is higher than the this standard 195 standard deviation. We get a RMSE score of 53 to 2.68. Here slightly different. For a base line decision tree model, this is 4 times lower than the linear regression model. A decision tree model is performing much better than the linear regression model. Standard deviation at 287 is slightly higher than the uh, is slightly higher than the linear regression model, meaning that the model is slightly overfitting on some folds, but it won't affect the performance of model that much. Okay, so now uh, we will create random forest model. So we will create a random forest model, uh, random forest regressor, and estimators. We will keep 10, and then random state we will keep to 0, and jobs we will run on all CPUs. Okay. Okay, so this is a random forest regressor with 10 estimators. Random state will be 0, and number of jobs will be -1. So we will run this now. Perform fivefold cross validation using base RF. Okay, and store the result in score. So score cross validation score. Estimators is base RF. X X will be 1 second. X will be X train. Y will be Y train, and then anything other. Okay, CV will be 5, and scoring will be a negative mean squared error. Okay, so run this, and we will notice the time for this. It will be estimator only. Okay, so it will take approx 3 minutes, I think. Last time it took 3 minutes for me. Okay, so this is cross validation score. So once it will run, then we will show the score for this. So it is running now. Then we will show the score. So what will be the observations? It is taking some time. Once it will be run, you will see that the RMSE score for the baseline random forest model will be approx this much. Okay, so this will be better than the decision tree model, or you can say lower than the decision tree model. It took 1 minute 53 seconds, but for my case, it already running from 2 minutes. I think approx 3 minutes it will take. Uh, to perform a random forest is the best performing baseline model with the lowest RMSE score. So I hope it will come out as the best model. Also, the standard deviation at 206 is lower than the decision tree. So standard deviation of this model we are hoping will come less than the decision tree and almost equal to the regression model, meaning it is generalized well on unseen data. Okay, it run successfully now. So it's take 3 minutes 6 seconds. So now display the score. Okay, it is showing 3996 point. So standard deviation is also lower, approx 198. Okay, so I hope this since this random forest has lowest RMSE value, so this is the best model we have till now. Okay, now we will do the feature selection. For this, we will do checking feature importance. Now we will check the feature importance of each feature using a random forest model, fitting the baseline random forest model on the entire train set to obtain the feature importance of each feature. Okay, so we will do that. So we already have base random forest dot fit xtrend comma xtrend comma y train. Okay, so we will do fit on this. For a feature importance, we should always keep in mind that we do feature importance part on the train only. We don't include test here. Okay, so run this. Now we will retrieve the feature importance scores from base random forest. So let's see random forest in SQL. Okay, so this is the random forest in SQL. Here, for finding the feature importance, we will use. Okay, there is a one term feature importance. We need to find that. Okay, 1 second. Feature importance. So this is the term actually. Feature importance. We use the impurity based feature importances. So this term we will use. Okay. Uh, Now retrieve the feature importance score from base random plus dot feature importance. So this feature importances give the importance of different features. I think this I have done for my help only. Now we will print like this means it is okay here, but we need to print them in the order and percentage of feature importance. So for this, what we will do, we will loop over sorted feature importances across as string column names. So for score, comma, name in uh, sorted, we will create a zip file for this uh, base rf dot feature importance. Okay, uh, comma, uh, xtrain dot columns. Uh, and for sorted, if we want them in the decreasing order, so we will mention reverse as false. Reverse equal to false. Then we will print feature importance of department. Okay, feature importance of is uh, score. Okay, so like this we will do. So run this. Here we are what we are doing. We are creating the zip for feature base random forest dot feature importances and extrain columns. So this will create the tuple of these, and we will the file will create the tuple of these. Okay, and then we are sorting them in the ascending order by mentioning reverse equal to false, and then we are creating loop for loop for score comma name, and then uh, printing their values. Okay, so here we can mention percentage also. Hmm, okay, so let's run this. Okay, we will do score into 100 for the percentage, and yours will be okay. So for sorting them in the ascending order, we need to mention reverse equal to 2. And for score, we will multiply with 100 for showing in percentage. So you can see that department has 63 point this much percent, size has this much importance. So department is most important feature. Then we have size, then we have store, then we have customer price index, then month, and so on. And these marked down 1, 5, 2, 4, and this 3. These are these are not much important. The feature importances are organized in a descending order, meaning the most important features are at the top and least important are at the bottom. Let's plot the feature importances on a bar chart for a better visualized visual look. Okay, so uh, we will plot a bar chart plotting the feature importance of each feature. PLT dot figure fixed size equal to 12 comma 7. Okay, now we will create a bar plot. Create a bar plot using explain columns and importance score. Okay, so we will use matplotlib for this plt dot uh, bar and xtrain xtrain dot columns. X should be capital and y will be uh, base random forest dot feature importance. Okay, feature importances. This is spelling will be feature. Feature importances. Uh, this X will be feature. Okay, Uh, convert feature into percentage. So this we need to convert into percentage. So as we done above, we will multiply this with 100 and color we will set to green. Okay, and plt dot x label, plt dot y label, plt dot title. Y label will be importance. Now this title will be feature importance of each feature. Okay, so now run this. So uh, actually these are not these x ticks are overlapping. So I need to change orientation also, rotation, sorry. Plt dot x ticks rotation, keep it 90 degree. So run this. Now see department has highest important, then we have size, then we have store, then CPI, and in this way we have. So okay, the feature importance of columns tells us which feature are most important to the model while making predictions. Here we can see that department column has the highest feature importance with 63.35%. Let's move on. Followed by the size column having 18.56% importance. Top six most important features are department, then size, then store, CPI, month, and a day. We will use only these features in our essential feature models. Now we will jump to essential feature models. In the essential feature models, we will be using only the most important features of the dataset in our models. The features are selected on the basis of the feature importance obtained from a random forest model. So we are selecting our features on the basis of random forest model. We will be performing five-fold cross-validation to validate our model. So here we are performing five-fold cross-validation. So we create a new this train data set that is X-train essential, and we will take department size store and CPI month and day, and then show the first five rows. So run this. Okay. Now we will again start with linear regression. So we name it essential LR. So equal to linear regression. Again we will perform cross validation. So cross validation score, then estimator equal to essential LR, and X is equal to X train essential, and Y equal to Y train. Cross validation equal to 5, and y equal to y train, and for score, scoring, negative mean squared error. Scoring equal to negative mean squared error. Okay, so this is the uh, code. Okay, so run this, and now we will display the scores. So display scores and then scores. So this is the score. Okay, so after performing a five-fold cross-validation on our essential feature linear regression model, we get a mean RMSC score of this much. The RMSC value has increased a little because we are only using six features. Previously, we have used all the features, but this time we are using only six features. But the change is very small. Still, the error is large, hence that this model cannot be used. Then we will essential decision tree. Okay, and then perform cross validation state cross validation score for this with negative mean squared error. So we will run this and we will see the score for this also. Okay, it runs successfully. Now we are displaying the RMSC score with display score helper function. So this is the score. Again, we get a mean RMSC score of this much. There is slightly deviation. This because it is like I have written that time for our essential feature decision tree model. The RMSC has decreased by a lot, even though we are only using six features. The standard deviation at 137 has also decreased. So here standard deviation is 65 only, and so it is very less only. So means it is generalized well on unseen data. Okay, so I hope these points are clear to you. Now we are creating random forest model. So essential random forest estimators will be 10, random state will be 0, and we will use all the CPU available CPUs. So run this, and then we will run this random forest on our essential data. So run this. This time, last time it takes 3 minutes. You will notice that this time it will take a very less time. Within half time, it will able to do. Then we will show the score. Okay, so this time it run in 1 minute. Okay, 1 minute 9 seconds. Previously, it takes 3 minutes. Okay, so now display the score. So score is also a list. The main RMSE score for the essential feature random forest model is this. Our model has improved even though we are using only subset, that is six features of the from the entire data set. It took 53 seconds to perform. For our case, it took 1 minute 9 seconds. The training time has reduced. RMSE is still significantly lower than the decision tree model. Now you can see the model comparison. Uh, okay, so for random forest, for baseline, this is the value, and for essential model, this is the value. Even after using six features, we are able to get minimum RMSE score. Essential feature random forest is the best performing model with the lowest RMSE score. It outperforms all the baseline and essential feature models. Okay. Now hyperparameter tuning of the model. Now we will do hyperparameter tuning for our model. Okay, and this hyperparameter tuning we will try to do in details, like we do in production. Creating the parameter grid. So the parameter grid will contain all the values of each hyperparameter to be used. Okay. So this code should not supposed to be written here, but it's okay. Uh, at the last I am going to write this code. So here what we are doing, we are creating parameter grid. The parameter grid will contain all the values for each hyperparameter to be used while searching for the best hyperparameter. So in parameter grid, we mention all the values of hyperparameter which we want our algo to search for. Okay, so here we are using n estimators as 10, 20, and 30. Max depth none, 2, 3, or 5, and max features auto 2 and 4. Okay, so run this. This is our parameter grid. Now temp random forest. Random forest regressor. Random forest state will be 0 and number of jobs will be -1. So we define the random forest. Uh, Now creating a grid search. So first of all, we will use a grid search for hyperparameter tuning. Later we will use Optuna, okay, which is very great tool, is very great library. So we will use that also. So first start with grid search. We will input the model parameter grid scoring method and number of folds uh, to use for cross validation into the grid search object. We are using five-fold cross validation here. So first create 1 minute. So first of all, create a grid search CV using temp random forest and store in grid search. So uh, grid search CV, and in grid search CV estimator will be temp random forest. Okay. Use parameter grid for hyperparameter tuning. Evaluate model using a negative mean squared error. Use five-fold cross validation. Uh, so first we defined grid search. Then in grid search we need to mention parameter grid. So we will mention this parameter grid. Then after parameter grid we need to mention scoring. Okay, so uh, here it is scoring will be uh, negative mean square error. Okay, so this is the all. Now also we need to provide uh, cross validation in this grid search. So cross validation will be 5 and n jobs will be -1. Anything else is pending grid use parameter grid hyperparameter tuning evaluate negative this much and five-fold cross validation and then all the CPUs. So this is grid search. Okay. Now run this uh, performing grid search. Here we will supply the data set to be used in grid search and initialize our search. So now we will supply the data set in the grid search and initialize the grid search. Okay. So uh, grid search dot it. Okay, and in fact we need to use explain essential comma uh, y frame. This is our grid search. So let's run this. This okay. The scoring parameter must be a string. Okay. Now run this. This will run this time. Now we will calculate the best RMS. Once this will run, then we will calculate the best RMSC score found by uh, grid search. Till that time, let's see. Grid search, maybe SK now. So this is grid search CV. Here we mention estimator, then parameter grid, then scoring and jobs. Refit is like when we find best parameters, we telling that fit on the com complete data with those best values. So it is default is true only. Then cross validation, verbose, no message are printed. Pre-dispatch error score, return train score. Then now cross validation result. This is the one attribute. A dict with keys as column headers and values as uh, columns that can be imported into Pandas data frame. Now it shows the best estimator that was chosen by the search. That is estimator which give highest score. It is the best score, mean cross validated score of the best estimator, best params, best index, parameter settings that give the best result on the holdout data. Okay, and best index, what is best index? The index of the CV result arrays which correspond to the best candidate parameter setting. This is a scorer. This number of conversation splits refit time second used for refitting the best model on the whole data set. Okay, it is still running. It is taking lot of time. Okay. For calculating the best RMSE score, we will use best score. Okay, it is taking slightly more time. This game best parameter setting that gives the best result. So dict with keys. Okay, Let it complete. It's already running from 6 minutes. Now, once it will run, then we will calculate the best RMSE score found by grid search. So for this, np dot square root minus and this grid search dot s score. Score. This code is like keep on running. But we have to wait till it is completed. After it will be done, we see that we get an RMSE score of this much, which is lower than our essential random forest model. This means that we have improved our model performance after tuning the hyperparameter. Also, let's find out the hyperparameter values which provide us the best RMSE score. The hyperparameter values which provide the best RMSE score, we can dot best params. Um, params. Then we are gonna use hyperparameter values in our final model. We find out the best hyperparameter combination for our random forest model. Now we will use the model with those hyperparameters as our final model. Using this final model, we will make prediction on our data set. Creating the final model, we will create the final random forest model using the grid search best estimators. Uh, attribute. Okay, what is this best estimator attribute? Estimator that was chosen by the search. That is the estimator which give the highest score or the smallest loss on the left out data. So this will give the best estimator. We will use this best estimator. Uh, okay, it's already 10 minutes, but it is still running. Create final random forest model from the grid search best estimator. Retrieve the best model from a grid search and store in final random forest. Uh, Grid search dot. Now, what we will do, we will create the final random forest from grid size. So retrieve the best model from grid and store in final. For retrieving the best model, what we will do, we will use best estimator. Okay, so grid search dot best estimator store store it here. Then we will be doing the fitting of final random forest model. After fitting the final model with the training data, we are ready to make prediction on the test set. Okay, thank God it runs now. It takes like a great time. 15 minutes it have taken. Sorry for this. I don't have a idea it will take this much time. Now we will calculate the best RMSE score found by the grid search. So we will use this code. So like this is the best best RMSE score 3722. Okay, so before this, what was the score which we have received? It was 3679. Okay, 3679. And here we are getting 3722, which is slightly higher than the last score. Means maybe there is not too much scope here for improvement. That's why. So this means that we have improved, not really, but for the sake of understanding, we have improved our model performance. Okay, okay. Let's find out the hyperparameter values which provide us the best RMSE score. So for this, we will use best params. So none auto thinking. Okay, so previously it takes max features as auto. This time it has taken as 4. We are gonna use these hyperparameter values in our model. Final model, we found out the best hyperparameter combinations for our random forest model. Now we will use the model with those hyperparameters as our final model. Using this final model, we will make prediction on our test set. Creating the final model. We will create the final random forest model using the grid search best estimator attribute. Okay, so now what we will do, grid search dot best estimator and store in final random forest. We have saved in it. Then this final random forest we will do dot fit. Uh, and after doing, because this will take some time, so after doing this fit, after fitting final model with training data, we are ready to make predictions on our test set. Since in our training set we have improved some features, so we will remove non-essential features from test set also, because number of columns should be same for the model which was used during training. If we take different number of columns during training and during test, then it will throw an error. We trained our model on only the most important features of the data set. So we need to remove the non-important features from our test set as well. We don't remove the non-essential features, our model will get an error while making prediction due to difference in shape of training and testing sets. Uh, Creating the test set with only essential features. So X test essential, and from X test we will take these 6 columns. Okay, so now we will do fit also, and uh, let this bit happen. Next in our next session, I will before starting the session, I will complete this, and then we will start from here. This is Optuna. We will use Optuna and see that what is the uh, uh, is there any benefit of using this Optuna? Okay, then we will make prediction. So, okay, guys, that's all for today.